All right. I'm going to go over an example of how you can find a height of an object without having to measure directly to the base of it. So we could use this for an example for measuring something we can't actually get to from where we're standing because it's too far away, because it's surrounded by a fence, because it's something wide like a mountain. This is the way that we can do it. My example is going to be the Eiffel Tower, something that's quite tall and has an awkward shape, and there's no way to actually get to it. So, we can still start off with the same type of diagram. We have the vertical, we have our hypotenuse, and we have that rectangle at the bottom. So we're still standing here. We're still with our little protractor looking up, and we would still get theta up here. Unfortunately, with this example, there's no way to measure the entire distance. So instead, we are going to physically move, get closer to the Eiffel Tower, and now we're going to have to draw a new diagram with a new angle. So this angle right here, we're calling it phi. So originally we had theta, which was the entire blue angle, and now we have phi, which is smaller because we moved closer to the Eiffel Tower. Everything gets weirder when we overlap, so let's look at this again. I'm going to draw them as separate things. We have the blue triangle. Let's call this point A, just so we can clarify, and we have theta. We have the red triangle, same height all the way to the left, but now we got closer to the Eiffel Tower because we moved to point B, and then we got angle phi. This is kind of convoluted, so again, extra credit, but notice here how we can have the same height here. The guy or girl who's doing this is still the same height. So let's just say their eyes, just to make this easy, is 5 feet. So then down here, it's still 5 feet for the rectangle height. But let's say the person moved from point A to B, that's 20 feet. So that's nowhere as one of our sides. So unfortunately here we're going to have the red triangle is X, and then the entire width of the blue triangle and rectangle is going to be X plus 20. So this is where we're going to get into some system of equations and do a little bit more work, and thus again extra credit if you choose to do an object like this. So let's set this up. For our blue triangle, we still use tangent because we still have our opposite and adjacent for angle theta. So we would use tangent theta equals, opposite would be X plus 20 over Y. And then if we go over to the red triangle, that's going to be tangent of angle phi equals, and this is going to be X over Y. We always try to get something by itself here. And with system of equations, we want it to be something that can cancel out. So for this, the easiest thing would be to try to get y by itself, because we know that trick where they can just swap over. So if we get y equals x plus 20 over tangent of theta, and then we get y equals x over tangent of phi. So now, because we have the same variable, we can set them equal to each other. So x plus 20 x plus 20 over tangent of theta equals just x over tangent of phi. So now that we have just x, no more y, we can solve for it. So again, these angles were the ones from the clinometer. So let's actually pretend and make up some answers here. Let's say angle phi is 17 degrees, angle theta is 18 degrees. So we have these two angles. Let's plug it in. So we get x plus 20 over tangent of 18. And then we get x over tangent of 17. We're trying to solve for x here. So we're going to cross multiply. So that means we're going to get tangent of 17 times x plus 20 equals tangent of 18 times x. We have to distribute. So we get tangent of 17x plus tangent of 17 times 20 equals the tangent of 18 times x. We want to get x by itself, so that's always get all the x's together. So to do that, we can subtract this over. So these cancel out, so we're left with tangent of 17 times 20 equals tangent of 18x minus tangent of 17x. At this point, it's probably easier if we just find the decimals of tangent. I just left my calculator at school, and my phone's in a different room, so I can't actually do this now. So now that we did this, we can combine these two terms right here, so we can get tangent of 17 times 20. If we combine this, we get tangent of 18 minus tangent of 17 times x, and then we divide that on both sides. Again, I know this is strange. If you are willing to try this out for one of your objects and you come to a reasonable answer, you will get extra credit. So we did that. So then now we have x is equal to tangent of 17 times 20 over tangent of 18 minus tangent of 17. So we can plug that into the calculator. If you haven't already, just to get rid of the trig, this will be x, which means we now have this value, and we can add 20 to it to find out the bottom of the blue triangle. So now that we have that, we can actually go in and solve for the height now, just like it was one of your problems where you could measure the bottom. So we had to do a lot of math, right? We had to do a lot of math in order to find that distance that we would normally just measure with a measuring tape, like you could if you could stand up to the object and take a tape measure and measure it to your feet. So extra credit, it opens up the world though, so you can find the height of a pyramid, the Eiffel Tower, an object really far away that you just is very inconvenient to measure that horizontal distance on the ground. So feel free to try it out. Again, extra credit if you're willing to go through all of that math that I highlighted with the yellow. I can help you with this a little bit, but because it would be extra credit, you need to try this on your own and let me know how it goes.